Good evening, everyone. Today our topic is paper battery. I'm Alekia, and he's Bharat.
I'm Markandayalu.
A paper battery is an electric battery which is used as a spacer formed largely of cellulose. It incorporates by nanoscale structures and to act as a high surface area electrodes to improve the conductivity. And in the creation of paper battery, there are different departments involved like material science engineering department and chemistry department. In August 2007, a research team at Rensselaer Polytechnic Institute, Dr. Robert and Broadbent, Ajayan and Omkaran, with a team of them in a joint appointment with the material sciences and engineering, they developed this paper battery. And in December 2009, Yushu and his team at Stanford University actually proposed a prototype, and finally they announced the paper battery with a terminal voltage of 1.5 volts. And this is the basic structure of a battery. And here anode, zinc is acting as anode and copper is acting as cathode. The positive energy is supplied from copper and the negative energy is supplied from zinc. It is a voltaic cell. And let us look at few batteries like a nickel cadmium battery. It is a rechargeable battery using nickel oxide and hydroxide, metallic cadmium as electrodes, and its terminal voltage is 1.2 volts. It has a very high specific power of 150 watts, and it has a long life with it can supply a bright light. It is generally used in UPS, portable power supplies, tools, and photography equipment is generally made up of these nickel cadmium batteries in flashlights, emergency lighting, and portable electronic devices. The disadvantages of this nickel cadmium battery is it has a less memory effect and it has many environmental hazards and the cost is very expensive. Coming to lithium battery, the lithium battery is constructed using a graphite rod and lithium cobalt oxide as electrodes, and the nominal voltage of this lithium battery is 3.6 to 3.7 volts. It has a very high specific power like 300 watts and it has no memory effect and only a slow loss of charge when not in use. So it is in use very much. It is used in laptops and it is very expensive, delicate, has internal assistance. And the problems with these conventional batteries are they have lower specific power compared to fuels, and the weight and size is very high. High charging time, it takes a high charging time. There were many environmental hazards and due to these batteries there may be corrosion and leakage problems and the cost is very expensive and there are also voltage restrictions in these batteries. And here is a picture of paper battery and the rest is continued by Bharat.
Generally, a paper battery is a flexible, ultra-thin energy storage production device formed by the combination of carbon nanotubes with a conventional sheet of cellulose-based paper. The name itself indicates paper battery. It is made up of a paper with the mixing of the carbon nanotubes, and also the carbon nano materials are one-dimensional structure. If you observe the carbon nanotubes, we can. This is the how carbon nanotube like this. This is the one-dimensional structure, and it can be bent and it can be twisted like this. Any can be bent and twisted. And a paper battery act as both high energy battery and supercapacitors. For example, if we consider a capacitor, we have two plates. These two are the induction plates. For example, if you consider here is the positive charge, automatically here it induces the negative charge. Here induces the positive charge and then here negative charge. positive charge and negative charge both are attracted towards. This is how the capacitor works. Meanwhile, here we have some electrolyte. This electrolyte increases the potential of the capacitor. So here is the picture for a lithium-ion paper battery. Generally, if you observe, this is the lithium-ion battery. Can you see this? Yeah. If you can see, the lithium-ion plus ions are moving from the one side of the plate, and negative ions are moving for the positive side of the plate. The carbon nanotubes, nothing but which color the black paper act as electrodes and allow the storage device to conduct electricity. And the paper battery provides a long steady power output against a conventional battery burst high energy. And for the fabrication of the nanomaterials, we use a small paper, and also on that paper we have to put some carbon nanoparticles. I mean the solution of the carbon nanoparticles. The paper is kept at the oven up to 1 degree centigrade Celsius, so it evaporates the water content on the paper. And the battery is ready, would prepare a terminal voltage enough to power an LED. Next slides will be continued by Markandeyulu.
Here is the paper battery making. Is the black molecule put into the paper, then cover with all the paper into the black molecule and put into the oven and heat into some pressure. Then it comes put into the light. It goes to open the light. And the advantages of the paper battery. Paper battery light, rugged, flexible, can be rolled and crunched, cut, made into any shape. For suppose laptops and mobiles have different types of batteries. But paper battery you can make in our own way. We can use 10 mm battery. We can cut into the paper 10 mm. The nano capacitor paper is compatible with the number of electrotypes like blood, urine, and sweat. If you stack 500 sheets of together in ray, that 500 times that voltage, if we rip into the paper, if you cut into power 50%, so we cut into the 50%, we can convert into the volt equal manner, and then that's why we have some voltage losses, and nano toxic, and hence can be used power pacemakers and RF tags. And another one is it is very useful for where burst of energy is required of operations, like most electrical vehicles. We saw most of buses failed with while accidents. Then it comes some burst. By using the paper battery, it's not happen. And the electrotype contains no water. Thus there is nothing in the battery to freeze or evaporate, potentially allowing operation in extreme temperatures. And the paper battery is environment friendly. In paper battery, the organic radical materials inside the battery are in an electro-permanent gas state, which helps it makes a smooth move allowing the batteries and charge lighting speeds. This battery, compared to the other batteries, it will charge 10 to 20 times faster. And the paper battery would be the answer of the electric energy storage problems. And limitations. Presently, these devices are only few inches across. They have to be the scalp up to sheets of newspapers size to make it commercially variable. Carbon nanotubes are very expensive, and the ideas still in the labs are not commercially viable. Paper battery will take the least 40 to 60 years to become a reality. Researchers in nanotechnology to mass produce nanotubes is promising. And applications. By using the paper battery, we make pacemakers, usually alternative to conventional batteries in gadgets, devices in space shuttles, power smart cards, RF ID tags, smart clothes. And here is some video about the paper battery.
Things about this process is really it's very simple, very low cost, it's very easy to do. We think this can really change how the way people make batteries. We would like to use this white color paper become a black carbon nanotubes, highly conducting paper. And also paper is lightweight. It can store a lot of energy. Without other that way, eventually your whole battery can get lighter and lighter. You can think about using these new type of paper batteries or silicon capacitors for large scale energy storage, including the energy storage device connecting with electrical grid to smooth out the electricity fluctuation, connect these batteries with solar cells, solar farm, connect with a wind farm. We can use these paper conductors for lithium-ion batteries used for the car. What we gain is we can reduce the dead weight of the batteries because paper is light. So,
Thank you, friends.
So very soon we'll see batteries in paper shape. Would it be less expensive, you think? Okay, and more efficient? It's easier to charge in 10, 20 times. That's amazing. Thank you very much for that. Yes, question, yes.
Yeah, here you have said that the paper is put in an oven. Whether you can put a paper in an oven, it will not burn.
By temperature, we will put that paper into the oven.
What?
We are putting burgers and all that into oven.
It is a paper, right?
It will not burn.
Why the paper will not burn at that much temperature?
By temperature only. Not at high temperature.
You said 150 degrees. 150 degrees, the paper will burn automatically.
Okay, so that's a good point. We don't want fire to happen. Okay, any other questions? That's a very smart question. Let us put it on tape.
For the Santosh question, the paper will not burn because they have placed some ink, nanoparticle ink, that will material. So that will capture the heat and it will generate as an battery.
Nano solution. That's a nano solution. Nano solution. Thank you very much.